Alrighty, in this lesson we are looking at quadratic functions in vertex form. So let's get started with our objectives. The first objective that we have is to graph quadratic functions of the form. There it is. You'll remember this is called standard form. By transforming the parent function, and the parent function is f of x equaling x squared. It is the most simple quadratic function you can work with. Everything else will look like it, but it'll just be a bit more complex. Our next objective is to write quadratic functions in vertex form by completing the square. This is a process we looked at in our last section, so this is an opportunity to work with it again. Lastly, we want to determine the vertex, domain, range, and axis of symmetry of a quadratic function of the form f of x equaling ax squared plus bx plus c. So again, given any quadratic function in standard form, that is standard form, we want to find vertex, domain, range, axis of symmetry. All really important elements. So let's get started with remembering a little bit of information from our last lesson. The value of what dictates whether the parabola will open up or down? What is it in that standard form that will dictate if it opens up or down? That is your A value. If A is positive, you'll have a happy parabola, because positive means happy, and it'll be opening up. If A is negative, when you're negative, you're sad, and you frown, and so it'll look like a sad downward facing parabola. Okay, now the value of what will dictate how narrow or wide the parabola will be. Well, that is again the A value. It's kind of, you want to think of it like a slope. If you have a slope of 5, that's really steep. If you have a slope of just 1/2, well, that's not very steep. That's going to be wide. That's going to be pretty flat. And lastly, the value of what causes a vertical, meaning up and down translation or actual shifting of the parabola. Well, that's going to be your C value. So we've talked about how A changes things and how C changes things. We're going to look at now kind of a different effect that can be performed on your graph. And we're going to do that in this first example. I want you to take a moment right now to use your graphing calculator to graph that red function g, the h function, and the f function. And I would encourage you to use 3 different colors for those, or at least label them so that you'll be able to differentiate them. Graph them, and then we're going to compare the graphs of all of them. So pause this video and take a moment to do so in your notes. All right, so when you graphed them, they should look like this. G is that red function, H is the blue, and f of x, that's kind of my dashed function that I'm comparing them to. That is my parent function. So let's talk about what happened here. Let's look first at our red function g. The g function, compare it to f, it is moved over to the right. It's actually moved over 2 units. If you look at the vertex, it's marked in green. The vertex has shifted over 2 units. And you can see also on the parent function, the point 2,4, it has, and you can see that with the little line, it has moved over 2 units. So there's that vertex moving over, there's that point moving over 2 units, and there is a third point moving over 2 units. The whole graph, every point on the graph is scooted over 2 units. Similarly, the h function, that blue function, take a look at its new vertex. It was right there, and now it has moved over 3 units to the left. Another point there moved over 3 units to the left, and 3 units to the left again. Every point here is being moved 3 units to the left of where that original function was. And look closely at those equations. When it was x minus 2, it moved 2 to the right. When it was x plus 3, it moved 3 to the left. Let's take a look at what this means. The big takeaway from all of this. If your function looks something like this, f of x equaling a x minus h squared, it's going to slide to the right if you have in parentheses x minus some h value. It will slide to the left if it is x plus some h value, and it's going to slide the number that is h. So if h was 2, it's going to slide 2 to the left there. Okay? So, another example. We are going to graph this function p and compare it to the parent function. So again, take a moment and pause this video and graph that. You can use your graphing calculator to help you and get some of those points. Make sure that they are drawn with precision, and also draw your parent function on the same coordinate plane to compare them. All right, so the graph should look something, well, no, it should look exactly like this. P of x is in blue, and that parent function is in that kind of dashed black line. So if we were to compare them, notice what happened here. Your vertex is now down and to the right. More specifically, it is down 3 units and to the right 2 units. And you can see I've kind of sketched out some other points and shown how they have moved over 2 and down 3, over 2 and down 3. This whole graph has shifted over 2 and down 3 units. Every point on P is 2 units to the right and 3 units down from that corresponding point on the parent function. So that's a nice comparison. And let's now take a little look here at a definition. When a quadratic function is written in its vertex form, which is what we've been using right now, it's f of x equals a, and in parentheses, x minus h squared plus k. Its vertex is going to be at hk, and its axis of symmetry is the vertical line x equals h. Now I want to make something really, really clear here. Inside parentheses, what do we have? We have x minus h. But its vertex is going to be the opposite of what you see. Notice you're looking at this and it's a negative h, you could maybe think of it. But in the vertex, you're going to take the opposite. So like in that previous problem, the vertex, it's kind of like it was the opposite of what it seemed to be. All right, we're going to look at some more examples, and I'm going to try and make this even clearer for you. So here we are. Example 3, we need to graph this function q. Take a little bit of time right now. Use your graphing calculator. Use the table and sketch that graph. You don't necessarily have to sketch the parent function, just that graph. Pause the video and do that right now. All right, it should look like this blue function, and I've kind of sketched the parent there just to give us a little bit of an idea of where we came from. You don't have to though. Let's talk about this function. Because it is in vertex form, it's very easy for us to identify our vertex. Our vertex is going to be at the point, check it, -4. I had to make that opposite of what was in parentheses. It is moving to the left. If you look back in your notes, remember those 2 arrows talking about direction of shifting? Well, here we are. It is moving to the left. It is moving kind of the opposite of the sign that you see. So the vertex is at -4, 1. The parabola is going to open down because your a value, what is in front of those parentheses, is negative. And because of your a value, that parabola is going to be flatter. It's a little bit wider, kind of remember like our Mr. Grinch. It is wider than the parent function because your a value is that fraction, that 1/2. And just like a line with 1/2 is kind of flat as its slope, well, this graph is kind of flat because of its a value. So that gives you a comparison. And those other points, I just found them by looking at my table, and that's a great resource to use. Otherwise, you would just have to plug in values to figure them out, which takes a little while. So that is all for this example, and that's it.